In this video, we're going to discuss how to properly navigate through some of the graphical and tabular results for column design in Adapt Builder. And we're going to be using Adapt Builder 2018 Build 3. This is an RC model, multi-story, so we're going to make sure we have only RC selected. There's no post-tensioning in this model. Similar approach can be used for models with post-tensioning. We'll go ahead and launch the file. Okay, and if we navigate, we'll go into multi-level mode, and we'll reset the view to show the entire model. So for this model, the columns are fixed to the slab. They participate laterally and in the lateral resistance. And if we go over to the load combinations, we're processing this for both gravity and just a few combinations, including wind loads. So we have the effects of wind, both in the X and the Y directions. This could be a longer list of combinations. We just want to reduce it down to something manageable for this model. So we'll select OK there. We're now going to just analyze the model, obtain a solution from the finite element run. You'll notice here this indicates that some of the load cases that are produced in the model, which are M0 and M90 for wind, those are the torsional effects. Those will not be included in this run because they're not assigned to the load combinations. That's fine. We'll select yes, and we'll go ahead and run the model. We'll save that. And we're going to create one design group that contains about 12 columns. We have columns in the vertical stacks, and I'll go ahead and mark those. These vertical stacks here and these 3 columns here, these are all 20 by 20 square columns. To show that visually in the model, we'll go back over to visibility, view settings, and I'm going to turn on the column dimensions. That will turn on those marks for the 20 by 20 columns, and we're going to design the columns from level 4 down. So to do this, I'll go over to column design. We'll select columns only. That will isolate, and I'll go into an elevation view, and I'm just going to select the upper columns. We'll deselect this one here, and from the visibility ribbon, we're going to hide the selection. And now if we come back to, for example, a 3D view, I can just select the columns that I want to group. Okay, and those there. So we have 12 columns. We're going to set to a design group. That's important to note that each selection has to be properly assigned to a group, and that group can either then be designed or code checked, and we'll talk about that here in a moment. So we'll come over to column design, define section type, or excuse me, we'll go to modify selection. We need to create the group, and we'll go under column design group, and we're going to say auto assign a new group. That will be shown and listed under the section type properties. So for this 20 by 20 group, we can assign the reinforcement necessary to produce a code check. So we need to start with something. We need to have a section with reinforcement assigned to columns, and at that point the program can then produce a design, which is a suggested design that is set to take care of the different forces acting on the columns, or we can code check and just determine interaction ratios based on the actions versus the capacity relative to this section. So we'll say that these are number 9s. We'll use a 3-3 pattern. We have roughly 2% in terms of the row, and then we're going to use number 4s at 6 inches for the ties, and that's our design group for this case. Now typically we would assign all columns to a group or individual groups if we wanted to design them. That's something that you must do in order to design or code check the columns. I'll come back over here to all columns, and if we go over to design settings, you want to make sure to set up the proper design settings. Here we're going to use the finite element solution as the force source. The global analysis will govern We don't have any post-tensioning, so hyperstatic doesn't impact this particular model. We're not reducing live load in this case, and we're going to turn off minimum moments. We'll focus only on the moments produced from the finite element results, and we will check slenderness. So we'll go ahead and make sure that those are set. And at that point, we can then determine if we want to code check or design the columns. Okay, now the difference between code check and design, and graphically this also pertains to the graphical results. Code check takes each individual column that's assigned to a group, and it checks that column for its own actions relative to the combinations that are being used to be checked against. So in this case, we had 6 combinations. For each individual column, we check the top and the bottom, and we have 6 combos. So we have 12 entries for axial, torsion, shear, moments about different axes, and so on. The difference between that and design group, or design the columns, is that the program for a design group really just sees a section. It says, here's the section assigned to this particular group, and for that section, obtain all of the different actions relative to every column within the group, apply it to this section, and produce an enveloped result. And not only does it take the actions, but it also envelopes, let's say, the unbraced length for slenderness. So that will actually produce a different result between code check and between design in this example. And we'll go ahead and we'll show that. So we're going to actually start with design, and we're going to refer to these column results here under analysis. This is our results browser. And we have 2 selections. We have design group results, which really apply to the design of a group. Therefore, for every column that belongs to a group, when we look at, for example, axial and moment interaction, it will be the same value because it's being designed as a group for worst case outcome. If you look at individual group results, this applies to the code check for each individual column. So this is pertaining to every column independent of the actual group. And that's why we recommend that you actually use code check first, determine where you might have issues, and then from there you can go into design mode. And that may actually lead you to assign columns to different design groups and create other design groups, because you might have columns grouped where you have essentially too much reserve capacity. So you may want to reduce the amount of reinforcement for a particular column or selected columns. So we're going to start off here by doing a design. We're going to select design the columns. It's going to show us we have 20 by 20. We have 12 of those columns. We can't individually select them because now it's designing it as a group. We'll select OK. Okay, once the design is done, the program shows us a current value, and it actually shows us the proposed design value. In this case, it's saying we need 25 bars. It actually could not converge to a proper bar arrangement for this column and the conditions for this design group. If you want to check results for the design, for the column design, you must use this option here. If we view the report, this shows us the design summary. Okay, and here's our interaction that's unacceptable. You can see here this number of vertical bars is based on what the design proposes. And then we have, again, we have 12 columns. We have top and bottom, so we have 24 times 6, and that should produce this amount of factored loads that the program is actually checking against for this design group. Note also that the unbraced length for this is based on the worst case for the entire group, and this is actually a cause for you kind of paring down the columns into different groups, even as a function of unbraced length. So this is a pretty long column in this case because of the fact that we've assigned columns of different embrace lengths to the same group. So keep that in mind. We'll now go ahead and just minimize that HTML file. And the graphical results now, if I look at the design group results and I look at status, this is based on the outcome that we just produced. So if we look at the axial moment interaction, these are all the same value because it is the design group result, not the code check result. Now what we'll do is we'll actually code check. Notice I did not update the design yet. So because I did not update the design, the reinforcement that's assigned to the section type is still based on the 2% row. Okay, that we still only have this amount of bars, eight number 9 bars in the section. Okay, so we'll go ahead and we'll code check now. And we could code check the entire group, meaning we're going to code check 12 columns independently, or we could actually select an individual column, right click, and code check that one column from this setting here. We're going to go ahead and just do the entire group. Now, one thing also to note is you'll notice here on the side we have a gradient scale for the interaction, and that's based on a setting under display. We can either have a gradient, or we can have what's called value, or we can have a status, and that's shown right here. This can change from value to status. Status is more binary. Is it acceptable or unacceptable? So it's not as informative as the value option. If we now look at the individual column design results, remember each one of the columns now is designed independently, so the unbraced length can change. The forces that we're checking the column for are those forces only acting on those particular columns. We're not designing it as a group. So if I look at status again, now everything works. If I look at the interaction, we can see we have some that are up here near 1 with the 8 number 9 bars, and some that are very, very low, like for example this column here is at 0.3 and so on. So we may want to regroup some of these. We may say, well, this column needs to be regrouped. We don't want to throw 8 number 9 bars at that column if we don't have to, and we can use an approach like this to actually reassign and regroup the columns. If we come down to this column here, if I click on the column, right click under column design, and I view the summary. This action allows us to produce the summary for the column code check, not the design. So here you can see for this column, the unbraced length, it's not 360, it's not a design group, it's an individual column of 113. This is our design group result. This is the individual column result. So we want to make it clear that for producing an output file, a summary for code check, you always should use the option here under View Design Summary. For the design result, we should use the option for under this design panel called Open Column Summary. Okay, and we can produce a report there. Now, if I update this and I apply that update, now the section has changed. Notice that this didn't change because I would have to run the code check again, but the section type has changed. We have now 25 bars in this column. This column just doesn't work under this size, but we have 25 bars, and in order to update the code check based on that new assigned reinforcement pattern, I have to run the code check again. So if I run this again, this number will change from 0.9 down to 0.6 because it's being updated per the new bar arrangement. Okay, and that changed just now from 0 to 0.6. Previously it was 0 to 0.93. This gets updated. If we produce that report again, we should see the update in the bars and so on. Okay, so that's how we can use both the tabular reports or the summary reports and the graphical reports, and how they reflect whether you've designed a column group or whether you've just code checked the columns. If you have any questions regarding column design in Adapt Builder, please contact us at support@adaptsoft.com. Thank you.